Hello and welcome everyone. Today we'll be talking about digital transformation, crafting a modern data solution for IT and OT. My name is Carm Taglienti. I'm the Chief Data Officer and Portfolio Lead at Insight, and I'm joined by Ross Turpin, who's an Industrial Engineering Manager for Wachter. So let's get started. We're going to talk about digitally transforming your enterprise and how it can provide many benefits to the organization. So first we'll talk about streamlining process flows. We can enhance our operational efficiencies, and a lot of what we'll be talking about today revolves around OT or operational technologies so that we can understand exactly how to manage our devices. We'll talk about the convergence of IT and OT, and as we start to increase the number of machines that we want to connect to our enterprise or to our networks, this allows us to be able to manage and maintain them and use the data that is being produced by them to increase our efficiencies. Certainly improved customer experience because as the devices that are on the edge or that we're using within our ecosystem are being used to help to drive our business, we want to make sure that the point of presence or where the customers interact, we're able to create that enhanced customer experience. Also, staff experiences for those that have to manage and maintain those devices or are in control of the machines and operations. They have the ability and the visibility to be able to see what is actually happening and then understand how they can manage and maintain them. And of course, all of this through the efficiency concept allows us to reduce costs. And so we'll talk a little bit about how to control the supply chain, the machine performance, and then predictively allow us to be able to anticipate downtime or replacement or even understand resiliency capabilities of our infrastructure, all because we have the ability to manage and monitor the environment. So I'll pass it off to Ross and we'll talk a little bit about implementation.
Yeah, I appreciate it, Carm. Like this is, it sounds like this is a fun, easy thing to do. Like, I don't know why every factory in the world isn't doing this. Well, it really comes down to these factories weren't built to talk to each other. They're built in silos that are every little machine within a factory floor may speak a different language. It may speak a completely different protocol. How do we break those all down, bring all that data together, and bring it up to the top so that we can get operational data across your entire organization in order to do stuff with it? That way you can make decisions that based on how the plants are operating, but you need a uniform data set to do that. And with the way these environments were constructed, they weren't designed for that. The challenge starts at the machine level. It's how do we make these machines talk to each other in a uniform protocol to bring it all up to the top so that the data scientists and the managers can do and see the performance of these machines and make decisions based on that are real time on how their plants are operating and what their environments are doing. So we have to build a solution of interoperability, common data sets across many different machines, across possible multiple factories, completely different environments, and give a single source data set upstream to give the enterprise insight across their entire organization, not just a single factory or a single machine.
So based off of what Ross was just talking about, we clearly want to make sure that we understand what the opportunity is. And a lot of the challenges he was describing in terms of implementation had to do with the fact that we have a lot of disparate sources of information, a lot of disparate devices that we would want to collect information from in order to be able to understand how to take that data, I like to call it a vapor trail, and then to use it in order to be able to create the efficiencies that we're describing. So some of these opportunities that we're talking about are really around how can we use the information that's coming from those sensors or actuators or devices that are on the edge or within the factory setting, and use that to be able to understand how we run our business more effectively or to make decisions more effectively. And so if we look on the far left-hand side, we have within the factory, we have our machines and our sensors and our actuators. We have cameras that help us to be able to monitor or other kinds of monitoring apparatus, which allow us to understand what might be happening on the shop floor. Then we want to be able to, within that context, not just collect the data, but be able to make it actionable. So how do we take that data and then make decisions with it? And what we're starting to see, of course, over time is the ability to be able to use analytics more at the point of presence, or the place where the actual decisions should be made, in terms of whether it's just controlling a device, for example, or controlling a line, or controlling maybe even an entire factory setting. So those are the kinds of things that we need to anticipate and then understand how they all cooperate together, as Ross was mentioning, to be able to make those decisions. So some of this comes right down to the fact that we want to understand what decisions do we want to make, what challenges do we have within the manufacturing setting, and then how are we going to collect the data in order to gain visibility into how to make those processes more efficient. So another part of this could be, as we think about scaling it, so we could look at the microcosm of how a factory might exist, whether it's at the line level or maybe at the entire factory level, or we might think about a collective of factories and how do they communicate in order to be able to understand how best to create these operational efficiencies. There could be certain behavior, for example, exemplified by one factory to another, and it would be interesting to use those learnings to prevent maybe the same kind of challenges or phenomenon happening factory to factory. So there are lots of interesting concepts in terms of being able to take this data to create intelligence that allows us to be able to run those facilities more effectively. And then ultimately, to the far right, at the enterprise level, this is where we can integrate the collection of information through the OT environment, and then use that within our IT or enterprise environment to be able to run things like machine learning algorithms and or control processes that allow us to be able to be more effective, and then project that knowledge back to the shop floor, the factory floor, to be able to ensure that the machinery can run more resiliently, more with higher availability. So these are all really important concepts that we'll go through, and it's all enabled by the data, and that's really the important part of this. So the idea here, we streamline digital transformation through this ability to implement with tools that sort of are an easy button for us overall. So if you think about it, and I'm sure many of you have had this challenge, not only is it about collecting the information from the devices, from the sensors, actuators, and or even just devices that may be producing information, like a camera, for example, on the shop floor, but it's also about being able to put that into a form that is accessible so you can make decisions from it. So this is really part of what the coalition that we'll be describing in just a few minutes allows us to be able to do. So driven by Intel and supported by Kepware and Insight, Dell, and Wachter, this is really just a mechanism that allows us to create a framework for the collection of information by talking with or taking advantage of industry experts like Ross, who are able to tell us this is how we should be collecting information. This is the kind of behavior that we should be able to use to make sure that that data is available to us for command and control purposes, and as I said before, for operational efficiency. So once we have that data, then we can implement our tailored solutions, which are able to then address your very specific needs. The data access is really the first component, but then the monitoring and management of the infrastructure is also critical. And so what we would want to do is have minimal disruption to the factory, or as much as possible. We all know that monitoring processes can be sometimes intrusive, and so we want to make sure that even though we want maybe monitoring the environment, we also want to make sure that it doesn't slow progress or slow the process overall. So monitoring needs to be as has as a little impact as possible in order to ensure that we don't disrupt how the factory operates, but at the same time take advantage of the fact that we can use the monitoring of our devices, equipment, and environment to be able to drive the operational efficiencies. And we'll talk about how we do that. So Ross, I'll pass it back to you.
So we partnered with Kepware as a core piece of this initiative because they've already in most of your factories, frankly. It is far and away the most common protocol gateways in the world when it comes to OT automation. We use them because you've got lots of different machines on the floor. They all speak different languages, different data types. They weren't designed to be interoperable. It gives us a uniform data set that can connect to each one with their individual protocol and bring it upstream and across to each other without having to have custom APIs, custom code, custom gateways for every single device. Having a single software piece that can talk to all of these is of what allows these type of things to scale. And it makes it where if you have add to your system, we don't have to come back in and figure out what we need to do. We've already got a universal gateway sitting there on your system that can accommodate any new technologies that you might bring in the future. Because anything we do, we want to be future proof. It does make a very uniform data set for sending up to the top floor in your enterprise level. It allows both lateral and vertical communication, and like I said, it's just been the industry standard. It's a great place to start with these type of projects. This is an example of how the general layout is. It's kept where it sits between your data layer and your shop floor. It'll connect directly to your devices out on your floor, reads all of the data that we want, the key data that from those, brings it up, puts it in a uniform data set, and then we can then have that data coming upstream. It gives you that interoperability between all your siloed devices. They communicate with basically anything that you're going to run into in the OT environment. I think their current data set is 150 plus drivers. Very rarely do you ever run into something that they do not support. It is a native application that works across them all, makes it very smooth and consistent across many, many different factories and applications.
Okay, so let's talk a little bit about what are some of the use cases. So we're setting the stage to allow us to be able to do a lot with the information that we're able to collect. And the what Ross was describing is really a mechanism by which we can create a standard framework that allows us to collect information and also make sure that it is resilient, supportable, can provide SLAs and disconnected kinds of recovery models, so the data can be collected and then, for example, in maybe remote locations, we'll be able to then still project that data to the location where it needs to be collected in order to maybe perform additional analytics on that information. Or within this kind of a context with call it a middleware component, this also allows us to be able to determine where is it that we would make decisions and what data do we need in order to make that decision. So you can actually say run logic or analytics on the device, you could run it on the edge, or you can run it directly within the data center. And so we'll talk about what some of those things might look like. But the use case is really, they could deal with things like RFID tracking, for example. You may be able to identify when particular stations are running low on inventory. Employee could enter a hazardous zone, for example. So for safety reasons, this allow us to be able to use vision-based systems and algorithms to be able to collect information and detect maybe safety conditions that might cause a violation, or even just sensors that could be put on doors, for example, open or closed based off of maybe anticipation of deliveries, or maybe even for things like environmental cooling conditions, etc. Whether it's hot or cold based on environment, and then or even things like motion detectors. You can identify potential maintenance that might be required to prevent unplanned downtime. And those are really big things, because anytime that, especially within the manufacturing scenario, anytime that the lines are down, well, that's just lost revenue, because if it's unplanned, then we have to worry about how much revenue are we going to lose because the line is no longer able to produce when it is expected to. So those are really big considerations as we think about it. And of course, this is all enabled by the collection of data or information. Now, Dell, one of our partners in the coalition, they produce equipment that allows us to be able to not only deploy the solution, but also to use gateway capabilities or gateway devices that allow us to be able to perform some of that command and control. And so Ross was talking a lot about the collection of information, and we use different kinds of protocols based on the devices that might exist. At any one of the locations. So you might be talking MQTT, for example, for sensors, or ThingWorx Always On is a communications mechanism, or maybe SCADA or OPC UA. So those are different ways of communication, and they're supported then by the not only the software that we were describing, but also they can run on these gateway devices at the edge. As think of those as sort of a remote data center, which allows these things to happen closer to the point of presence so that you don't have to worry about round trip to the data center, just as an example. So that's the idea here, is to ensure that not only do we have the software that's able to allow us to collect the information and perform the OT capabilities, but also the hardware that is easily deployed in order to be able to connect everything together with high availability and resiliency and fault tolerance within our environments that allow us to be able to ensure that we can process all of that data and create a reliable infrastructure for data collection and decision making.
So Wachter is unique in the OT space in that we have full stack of OT personnel. We can provide everything from electricians pulling and terminating the wires to data techs setting fiber and network lines to the engineers that are helping solve your problems. Our teams are OT specific. We don't work in any commercial. We don't do anything outside of the OT environment with those teams. Uh, so we know these environments in and out. We know the safety. We know how critical keeping plants up and running and the things that require them to do are. Uh, our engineering team specializes in listening to what your problems and pain points are and developing solutions that are unique to your system, not just handing you something that's cookie cutter and that you have to make work in your environment. We pride ourselves in helping solve your problems and making your plants and factories run in the most efficient way possible. Uh, we can work in any environments there are within the OT world and nationwide, certain countries around the world also. But we are one of the few companies in the United States that has a full W-2 workforce that handles all aspects of the OT environment.
Yeah, so that's great. So as we think about the different capabilities that we have, capabilities really provide the, I'll call it the groundwork that allow us to be able to take advantage of technology to be able to solve complex business problems. The other big component of all of this, especially in this domain, is the fact that you need industry experience, and certainly through Wachter, through the other key members of the consortium, including Insight, we have the industry experience that allows us to be able to deliver according to best practices solutions in things like TSA compliance, for example, or really just focusing on understanding what are some of the security mechanisms that should be put in place in order to follow best practices, or even for compliance purposes. Cybersecurity remediation is another big one. So anytime that we are talking about the collection of information from devices, communications protocols to sensors, actuators, anything that could potentially have a communications mechanism, it becomes part of our cybersecurity landscape. And so we want to ensure that we are putting in place the correct cybersecurity protections so that we don't expose ourselves as it relates to cybersecurity. In cases like global oil and gas, or even aging factories, to ensure that even though we may retrofit devices to be able to collect information, the power that is put on them, especially as it relates to communication and being able to execute potential programs or software that we would put on them, makes them a potential vulnerability for cybersecurity. So we need to ensure that we are putting remediation strategies in place. Clearly, temperature and compliance monitoring are really important in most environments, especially manufacturing areas. And it also has to do with what kinds of controls is the organization or within the industry are you putting in place. And here, this could be steel manufacturing, for example. Temperature is going to be key. Camera analytics can be used for heat sensing, not just visual. It could also be infrared kinds of monitoring that we could use and take inputs from. Gas and heat emissions, for example, is another key one. Another area is automation. So automation reimagined is another way to think about how are we going to, or can we trust automation in the context of being able to accomplish specific goals. So understanding the control limits as it relates to the execution of automation really allows us to ensure that step by step defined processes can be executed so that we can understand with a high degree of confidence and clarity what those steps may be through the control process. So in that context, then Insight will deliver smooth user experiences as well. So we're talking a lot about the control of the devices and collection of information. Another thing that I started off in the beginning of our conversation was really talking about what does the user experience look like. And so we really want to understand not just the integration to the device, but at what point does the human get involved in the decision-making process. And so being able to present information to a human in a consumable way allows us to be able to ensure that the experience is productive, and it also allows you to be able to, for example, make decisions without fatigue. If you are watching a camera device, for example, and your job was to watch the camera input 24/7, well, you probably would fall asleep watching a camera. So you're not going to really be able to do your job effectively if you're really just the experiences watching a video feed. So in those particular cases, then if that is still an important characteristic, camera feeds are really popular, especially for all kinds of object detection and ensuring that we are performing certain operations, especially safety related on the shop floor. Well, these allow us to be able to then use analytics to help augment the human's ability to make decisions. So in that case, we could use alerting or object detection or potentially even a multitude of tasks as we start to think more about AI techniques in order to make the experience better for the end user. So these are really going to be important characteristics, or even dashboards that could indicate potential, control limit issues, where we have maybe sensors that are reporting measurements that are outside of the control limits. So these kinds of things can help us to be able to understand how humans can take action more effectively, or even in certain conditions automatically shut things down in terms of the experience, but then have the forensic evidence to be able to understand why these things may have happened, and then the ability to be able to perform the analysis of potentially why a particular situation may have existed, and then allow us to be able to use that to learn and to be able to make the experience better in the future. Okay, so next, we'll talk a little bit about why our Wachter and Insight bridging the gap between IT and OT. And I think a lot of what we had already explained up to this point is really just sort of helping you to understand not just the fact that we have data and that we can run analytics against it, and we can, create lots of really interesting visualizations and create and an awesome user experience that allows you to be able to manage your environment more effectively. But in a lot of cases, we need more data in order to be able to do that effectively. And that's where the Wachter operational technology mechanisms come into place. So if we collect the information, we make it available, we can now accentuate our ability to be able to perform a lot of those IT operational characteristics, including things like automation or analysis, and make sure that the workflow now is streamlined so that we can create these efficiencies within the organization. And Ross, I don't know if you have anything else you want to add here, but feel free.
No, one of the things I want to add is that I think you covered it very well, is that the unique approach to this is an IT and an OT integrator working together. That is not industry common. Generally, the IT integrator says, hey, we need all this data. And then the plant will contract with their OT integrator to then get them this data. They're then the go-between between these two companies. We're coming with a single source approach. We're going to work with you to make sure that we get you a single set of data that meets your needs, that you're not having to be a go-between between two companies trying to decide whose responsibility is one piece. This is a single source solution that from the shop floor to the top floor is coming from one place. We're applying it with a very uniform hand and getting you the solution you want without having to worry about multiple companies and multiple contracts trying to solve that problem.
Yeah, that's awesome. And it really is, like you said, it's not common, and it really helps to open up and to enable this sort of digital transformation journey that we've been describing. So making data available and really enabling the IT processes with OT capabilities is relative, it's unique, and it actually can help you to create those efficiencies that we've been describing. So how can we help you in your digital transformation journey? Well, first let's understand what the needs and objectives are, because that's where it always starts. It's not just a matter of say, hey, let's go out and buy some software and then we're ready to go. It's really let's understand what the problems are, how we can create efficiencies, and almost to an extent also understand what is the ROI. Like those pain points are pain points for a reason. Does it mean that the line has been down, or if the line does go down, does that mean that we're going to lose millions of dollars per minute, per hour, whatever the time frame might be? So let's first understand what that business challenge might be. The second step is to understand the infrastructure. Like, do you already have processes in place that allow you to be able to sort of produce the analytics that allow you to understand what the operational efficiencies might be? And maybe there are certain areas where you're blind to what information might be available to make those processes better. That's where we can look at OT capabilities to be able to collect that information to make your processes more effective. And so understanding the infrastructure is a really important part of that, because it might just be a matter of maybe we do need to deploy some edge hardware. Maybe we do need to establish some better network connectivity. So those are the things that we can talk about and understand from an infrastructure perspective. And then third, creating a blueprint so that we can understand what are the steps that we would take in order to be able to get you on that digital transformation journey. And it doesn't have to be a boil the ocean scenario. And it doesn't have to be something where we're going to say, okay, it's going to take 3 years and then we're going to be done. It's more of a matter of just understanding like what are those pain points? How do we start the process? How do we begin the journey? And then it's always a learning experience. And so how do we take advantage of these OT capabilities? How do we integrate them into our current IT systems and capabilities? And then how do we even transform the business maybe to do things that we could never do before by applying these techniques? And so these become really sort of the next step for us in our overall journey. So let's talk a little bit about some case studies. So if we think about all of the capabilities that we've been describing, it's really important to understand like what kind of impact can this have. So in this first example, it's just really a die-cast part manufacturer. They really wanted to improve their first part yield and the equipment efficiency. So basically, what they're trying to do is look for ways to reduce work center downtime. And we see this also, we have other examples in mining operations. It's just another good example of a similar kind of problem, but you have very expensive equipment. You want to ensure that the equipment functions effectively and efficiently, and then you are able to ensure that it can keep running at operational capacity at the highest extent possible. So that throughput you want to ensure that you're able to maximize. And so this is really about that. So we can capture the information by using these OT systems, and then we can use that to be able to feed our analytics systems, and then understand how to create operational efficiencies in workflow processes or the overall process cycle. And so that's really the important part of understanding how we can do that. So like the FPY, for example, you can increase that yield, and then also ensure like the equipment is being used to the maximum extent. A couple other examples are around oil and gas, just as one example. And so basically IoT edge-based solutions that use AI models in order to predict when oil pumps were going to fail. Again, predictive maintenance and analytics, super important in these environments, because really when you think about the manufacturing cycles, we want to ensure that these systems can run at operational capacity during the expected throughput time period. If the systems do go down at any point in time, then you're losing money, and so you don't want to do that. That's really an important part of it. And then the last one is again just sort of a visual perspective on virtual factory models, which allow you to be able to simulate how things may run to look for operational efficiencies potentially within the environment by capturing real information that allows you to then use that real information from the IoT sensors by using OT mechanisms, and then allowing you to be able to create simulations which are modeled after the real data. But this is how you can then really just understand where there might be opportunities to be able to do better.
At the base layer, we've got Intel. Pretty much everything we're running on your systems, our systems, is going to be based on Intel. Intel's who brought a lot of these companies together and helped put this, spearheaded this operation. We then are using Kepware as the data acquisition and interoperability layer. We're partnered with Dell for hardware if we need hardware. Also happy to use whatever you guys have as an industry standard, but we know Dell stuff works. They've been a great partner with us in this coalition. Wachter, my team, we're the guys that are going to be the boots on the ground. We're going to go install the hardware. We're going to write code if it needs to be. We're going to make sure everything is flowing upstream. Then we're going to hand that off to Insight, and their data scientists are going to give you guys your dashboards and your actionable data that you can work from. And with that all together, you have a single source solution that solves your problems. We've moved past the days of you having to put all of these different pieces together and figure this out yourself. We're here to partner with you to help you figure this out, find out what your needs are, and develop a solution to meet those. This isn't a cookie cutter off the shelf solution. It is a solution that we will build to solve your problems and get you the greatest ROI to run your factories or your equipment.
Okay, so first of all, I want to thank you all for your attention today. And Ross, thank you for joining me today in this session. And the one thing that is unique, and Ross said this a few times with this coalition, is that we really brought together experts in this entire field in order to be able to deliver a solution that works. And it really is a true definition of collaboration, but also integration in terms of creating these kinds of solutions. And so it makes things a little bit easier for you as an organization to be able to take advantage of the capabilities that are easily deployable into your environment. So if you do want to take the next step, make sure to reach out to us. We'd love to have a conversation with you and to start that journey with you in your digital transformation.